The ocean often appears calm and empty at first glance, as if nothing important is happening beneath the surface. In reality, decisions are forming quietly in the dark water, long before any movement becomes visible to the eye. Beneath the surface, distance is measured, timing is evaluated, and positions are chosen with patience. Survival here rarely depends on speed alone, because the sea rewards those who move at the right moment. Most predators react the instant an opportunity appears, driven by hunger and immediate instinct. Once movement begins, the hunt often becomes a straight line forward, with little room to pause or reconsider. This reactive style works for many animals because it is fast and simple. But it also creates limits, because a rush chase can waste energy and allow prey to escape through one small mistake. Orcas do not rely on reflex as their first move, and that difference changes everything. They pause, observe, and assess before committing, as if the hunt begins in the mind long before it begins in motion. Before the chase starts, the ocean may look quiet and ordinary to us. For orcas, this is the most important phase, because information is collected and the situation is shaped without revealing intent. For orcas, hunting does not begin with pursuit, and it does not begin with noise. It begins with positioning, because the best hunt is one where escape routes are closed before the prey even understands it is being targeted. What follows is not chaos or improvisation, and it is not an animal simply reacting to hunger. It is execution shaped by intent, where every move has a purpose and every second is used efficiently. The orca, often called the killer whale, is one of the most recognizable predators in the ocean. Its size, speed, and confidence create a presence that signals dominance long before it reaches its target. Few animals challenge an orca directly when it enters their space. Power and control are obvious in the way it moves, because its body is built for force, endurance, and quick bursts of acceleration. Yet strength alone cannot explain why orcas dominate so consistently across so many oceans. Many predators are large and fast, but they do not hunt with the same precision or win with the same reliability. What separates the orca is not muscle or speed, but the intelligence guiding each decision. The real danger is the planning behind the movement, because strategy makes power more efficient. An orca's brain is large and highly developed compared to most marine animals. It supports learning, memory, and social coordination, allowing orcas to solve problems rather than simply react to what is in front of them. This brain supports patience, and patience is rare among predators. Orcas can delay action, hold position, and continue observing, as if they are waiting for the exact condition that makes success almost certain. Many predators are pushed forward once a chase begins, because momentum becomes commitment. Orcas can resist that pressure and choose restraint, which allows them to control the tempo instead of being controlled by it. Before a chase ever starts, orcas evaluate distance and angle around their prey. Positioning determines how the hunt will unfold, because the best attack is often the one that never becomes a long pursuit. Orcas recognize patterns in prey behavior and movement, and adjust their approach accordingly. Experience shapes expectation, so what looks effortless to us is actually the result of memory guiding real-time decision-making. Planning happens over seconds and minutes, not in an instant. Orcas choose the moment of action carefully, because timing can replace speed when the target is forced into the wrong direction. This is why two hunts rarely look identical, even when the prey is the same. Orcas read conditions, select the method, and adapt, turning the hunt into a flexible strategy rather than a single fixed routine. Strategy is not automatic, and it is not simply born into the body. It is refined through learning, because orcas build skill the same way humans do, by watching, repeating, and improving over time. Young orcas are not born knowing how to hunt effectively in every situation. Skill develops slowly through observation and repetition, and the early years are filled with watching adults and absorbing the rules of movement. For years, young orcas follow and observe adults from a distance during real hunts. They learn where to position themselves, how to keep spacing, and how to move without breaking the formation of the group. Many hunting movements are practiced without real prey present, like drills before a real operation. Coordination is refined without risk, so when the moment comes, the body already knows the rhythm. Mistakes are expected during this process, and failure becomes information rather than loss. A missed approach teaches timing, a broken formation teaches spacing, and each attempt shapes the next decision. This kind of learning cannot be explained by instinct alone, because it requires guidance. Experienced pod members shape behavior over time, turning raw ability into reliable technique through constant exposure and correction. Knowledge passes gradually from older orcas to younger ones, not in a single moment. Hunting skill is built, not inherited automatically, and that is why young orcas take years to become truly effective. Over time, these lessons become consistent, and education replaces impulse. The result is a predator that does not depend on luck, because success is constructed through practice and coordination. Different orca pods hunt in very different ways across the ocean, even though they are the same species. These differences cannot be explained by genetics alone, because the techniques match local environments and prey. Some pods specialize in fish, while others focus on seals, and some target large whales. Each group adapts its method to what is available, and the strategy becomes a signature of the pod. An orca raised in one pod does not automatically know how to hunt like another. Without learning, certain prey remain unfamiliar because the knowledge required is cultural rather than instinctive. This is what scientists describe as culture, where behavior is learned socially and preserved over generations. In the animal world, this level of cultural transmission is rare, and it changes what the predator can do. Culture defines capability as much as biology does, because tradition shapes skill. What a pod hunts, how it hunts, and when it hunts become patterns that are reinforced across time. Hunting techniques remain consistent within pods for long periods, even as individuals change. Knowledge survives because it is taught repeatedly, and because success rewards the behaviors that the pod preserves. Culture can also limit behavior as much as it enables it, because switching styles is not easy. An orca cannot simply decide to hunt new prey without learning the technique from a pod that already knows it. Orcas rarely hunt alone when targeting complex prey, because success depends on coordination. A pod can control the situation in a way one individual cannot, and teamwork turns intelligence into real advantage. Before the hunt begins, orcas position themselves deliberately around the target. Each distance and angle is adjusted, because the goal is not simply to chase, but to control where the prey can and cannot go. During the hunt, different individuals take different roles based on timing and experience. Some herd the prey, others block escape routes, and others wait for the moment when the prey is forced into a weak position. These roles are not random, and they are not performed without purpose. Each position supports the overall strategy, so the hunt becomes a shared operation rather than an individual race. Movement becomes guided rather than chaotic, because the prey is pressured into predictable paths. Orcas reduce uncertainty, and reducing uncertainty is one of the most powerful advantages intelligence can create. Timing is critical in this process, because formation depends on synchronization. A single mistimed move can break the sequence, weaken pressure, and open a narrow escape window that the prey can exploit. Communication allows quick adjustment during the hunt without losing control of the formation. Orcas respond to one another constantly, using cues that keep the group aligned as the situation changes. Sometimes sound is used to coordinate movement, and sometimes silence becomes the better choice. Orcas can adjust their behavior depending on what the prey can detect, and that awareness shapes every decision. The hunt unfolds like a sequence of steps rather than a single burst of speed. Each action prepares the next, and the prey is guided toward an outcome that has been shaped long before the final strike. In some environments, prey appears unreachable, like seals resting on floating ice. The ice seems protected by height and stability, but orcas identify weakness not in the prey itself, but in what supports it. A direct attack would fail in these conditions, wasting energy and revealing intent too early. Orcas recognize the problem, then shift the target from the animal to the environment holding it in place. Instead of attacking the prey, orcas focus on manipulating the ice. The ice becomes the real target, because if the platform fails, the prey is forced into the water where orcas control everything. Before moving, they align carefully in formation, adjusting distance and spacing. This setup matters because the entire plan depends on multiple bodies producing the same effect at the same time. Swimming together, orcas generate controlled waves that build and travel toward the ice. The waves are timed, not random, and the goal is to destabilize the platform with physics rather than brute force. The ice tilts, the prey loses balance, and the water becomes the trap. The hunt succeeds not through overpowering strength, but through understanding how force moves through the environment. Precision is critical because small errors can reduce wave strength and break synchronization. If the wave arrives weak or mistimed, the prey escapes and the pod must reset the entire sequence. In Antarctica, this method becomes refined into a signature strategy known as wave washing. The ocean becomes a tool, and the pod becomes the instrument that plays it with timing and control. Young orcas practice this technique repeatedly, sometimes without prey, to learn spacing and rhythm. Learning happens long before success is required, because training builds reliability when risk is highest. Risk is high, but the payoff is significant, and strategies improve with experience. Over seasons, the pod refines timing and formation, turning a difficult hunt into a repeatable operation. What looks like chaos to a distant observer is carefully engineered in the water. The difference is planning, because planning turns danger into a controlled outcome rather than a gamble. Communication continues throughout these hunts because coordination cannot collapse mid-sequence. Sound and silence are both tools, and the pod chooses what to use depending on the prey and the conditions. Orcas adjust their vocal behavior based on what the prey can detect, because sound travels efficiently in water. This awareness shapes approach, timing, and distance, keeping the prey uncertain while the pod stays aligned. Not every hunt succeeds, and failure is part of the process rather than an exception. Orcas fail, reset, and try again, because intelligent predators learn through repeated exposure to real conditions. Each failure provides information about timing, spacing, and prey response. Strategies are refined rather than repeated blindly, and this is how hunting methods evolve within pods over time. Techniques change as pods adapt to new challenges and new opportunities. What works survives and spreads, and what fails is abandoned, leaving behind a sharper and more effective strategy. This adaptability means no prey remains safe forever against a thinking predator. Orcas adjust to behavior, environment, and weakness, making them dangerous not only because of power, but because of flexibility. Even large sharks can be vulnerable to precision attacks when orcas understand anatomy. Orcas target critical organs, and experience teaches them what disables prey quickly and efficiently. They adapt methods to different prey types, shaping strategy to fit the target. Flexibility becomes an advantage that grows over time, because learning expands the range of what is possible. Orcas remember locations where prey migrate seasonally, and memory guides movement. They return at the right time, not by accident, because the ocean becomes a map written in experience. Waiting becomes part of the strategy, because arriving early or late wastes energy. Orcas use timing as a weapon, showing that intelligence is not only action, but also restraint. Humans often describe orcas as brutal, because we see the outcome without the calculation behind it. What looks violent is often precision and efficiency, built from learning rather than uncontrolled aggression. Orcas are efficient, not cruel, and their actions are controlled. The hunt is a solution to a biological problem. executed with clarity rather than emotion. Attacks on humans in the wild are extremely rare, which suggests awareness and discrimination. Orcas recognize difference in context, showing that their intelligence includes understanding, not just force. They are not confused predators that strike at anything that moves. They choose, and that ability to choose is part of what makes them both fascinating and unsettling. Orca intelligence exists without human morality, which makes it difficult for us to interpret. There is no concept of mercy, only success, failure, and the need to survive within a harsh environment. Evolution rewards success, not kindness, and efficiency becomes survival. The ocean does not care how victory looks, only that the predator remains capable and the pod remains fed. When the hunt ends, the ocean returns to calm, and the surface looks peaceful again. Chaos lasts only moments, because the plan was never chaos, it was control. The orca does not linger, and it does not need to prove anything after the outcome is decided. The strategy is complete, and the pod moves on as if nothing happened. This is why the orca stands apart from every predator in the sea. Not because it is stronger, but because it thinks first and uses intelligence to make power inevitable. In a world driven by instinct, the orca proves a final truth that is hard to ignore. Intelligence can be the deadliest adaptation of all, because it turns hunting into certainty.